Welcome to the latest edition of Astraveo's Coast-to-Coast podcast of astronomy, science, and the world around us. My name is Joseph, he's David, and we're just two friends who happen to be professional astronomers with a deep love of telescopes, astrophysics, and all things science. We've got a great show for you guys today. Today, we'll be talking about our nearest neighbor and the brightest object in the sky, besides the sun and moon, of course, Venus. Did you know that we've sent many unmanned missions to this mysterious planet? And you're in for a real treat because David here happens to be an expert on this stuff specifically. So, David, can you tell us a little bit about your background with Venus?
I thought you were going to say that I've been to Venus.
That's just part of your background.
That's part of the background. That's right. It's my origins. I had a Venusian passport. Yeah, I'm not sure my background is that strong, at least compared to yours. But I first noticed Venus when I was about 7 or 8, with my sort of fabled tale of getting into astronomy, and my mother buying me this little small aperture telescope. And of course,
that's not what you meant when you said you were an expert in Venus, right?
That's basically it. That's it. No, there's a bit more. But that was one of the after the moon, and I think I did the moon, Jupiter, Saturn. Maybe I went to Venus next, and I saw it had a phase, had like a crescent, and I thought there was something wrong with the telescope because I thought, what's going on? That it's all sort of dark on one side and bright on the other. But yeah, that was a real sort of seminal moment of maybe sort of Galileo-like that. You can have these spherical objects in the cosmos. It was wonderful. But I did teach solar system astronomy at both Vanderbilt University and University of Hawaii. So obviously the comparative planetology was pretty important for that course. So that was really interesting, where you really learn about how to compare all the other planets basically to the Earth. And one of the biggies you always do is Venus, because it's essentially considered our sister or twin planet. For some quite specific reasons, which I'm sure you know a little bit about. So I'll let you talk us through some of those if you wish.
Wait, so actually, I'm pretty curious about this comparative planetology thing. So there's a whole area of just comparing planets to the Earth itself.
Yeah, well, especially I mean, yes, because obviously one can compare, say, the Earth and Venus and come up with all kinds of similarities and differences. And then you can do the same with Jupiter and Saturn and say, well, they don't have a solid surface, at least not at the upper levels. Of course, they may lower down because of the high pressure, but they're much more massive. They're compositionally just completely different. Their orbits are completely odd compared to ours, in the terms that the orbital period of Jupiter is, I don't know, 11.86 years, something like that, 11.9 years, where we orbit the sun in 1 year. So just everything is very, very different with the other planets. And so it seems natural that you compare yourself to others, right? We do that in everyday life, and I think we do that with the planets too.
That's really interesting. So it's like using Earth as a reference point.
Absolutely. I mean, that's the only great reference points we have, right? We can measure our planet's properties really well and really easily. And so it seems really natural to compare yourself to the other planets.
That's really, really cool. Actually, to be honest, this is prepping for this stuff was the first time I'd heard about comparative planetology. So, I mean, I knew about planetary sciences, but I didn't know that that there was a dedicated field, or like a dedicated sort of area just for kind of thinking about things in terms of Earth. So that's really, really cool. So
absolutely,
I love the story you told about your early expertise with Venus. So obviously there's like a personal connection for it, but why is it so interesting, like in general? Like why do we care about it as astronomers?
Venus itself or all the other planets?
I'm sorry, Venus itself.
Venus itself.
Not,
well, it's
not all the pretty planets are obvious. They're pretty.
Yeah, that's right. Mercury, we don't care about Mercury.
No, I'm lucky if I get a color out of my image with Venus. Why should I care?
I know, that's right. We apologize to all the other planets. Well, so Venus is a funny one. It's really it's called Earth's twin or Earth's sister, and it's sort of not obvious why. But the most distinct reason is that it's very similar in size to Earth. It's about 81% of Earth's mass, so it's very similar in mass. It has rocky composition, similar to Earth. Its diameter is very, very similar to Earth. It's about 600 kilometers less wide than Earth. So as I think you wrote me some notes this morning, it's 36,000 Eiffel Towers across, which is a great way of putting it. Now, given how much they charge you to climb the Eiffel Tower, I can't imagine the price to walk across Venus. That's a lot of
Doesn't it
money.
help you put it in scale? I mean,
It
I
really
can't
does,
imagine
actually.
things unless things are in either Eiffel Towers or giraffes, or if I'm thinking about price, I need it in iPads. That way, it really helps me visualize the scale.
Okay, I'll try. I'll think of that next time when I speak to you. It's like, it's sort of one rotation of Venus's orbit past 12 o'clock. We need to do something.
Wait, so that is really interesting though, how similar in size it is to Earth. Actually, a lot of those numbers kind of remind me of my own sister, actually. 81%, because she's about 81% my mass, similar in size and rocky composition. So
I'm not even touching that one, Joseph. I suspect you're not getting a birthday present this year, that's for sure. Excuse me, have a bit of
if you're
today.
watching this, I love you very much.
Yeah, no, she's a nice girl. Well, so it's very natural then when people are similar, you compare them. Well, we compare ourselves to Venus because we're similar, right? Now, Venus has got us beat on a few things, though. It's the second planet from the sun, and it's much closer to the sun. If we're 1 meter away from the sun, for instance, Venus is only 72 centimeters away, so it's
Oh,
0.72 astronomical units.
wow.
So it's much closer, 30% closer than we are, which naturally means one would expect it to be much hotter, which it is. But it's got a very curious characteristic in the fact it's actually much hotter than Mercury. Now, Mercury is much closer to Venus, to the sun than Venus. So one has to ask the question, why is Venus so hot if it's farther away?
Right.
And that's a sort of question I could put to you as if you were in my comparative planetology classes. How can you easily explain that?
Well, I know Mercury's atmosphere has been largely stripped due to the stellar wind, and so there's not going to be much trapping the heat there. And so we know the greenhouse effect is a big part of Venus's sort of atmospheric dynamics, because it's got that very high carbon dioxide content atmosphere, like Earth in 150 years. So I mean, but it's really, so I assume it's the greenhouse effect. But it's really interesting that just the greenhouse effect can make Venus, the surface of Venus, hotter, much hotter than a planet that is way, way closer to the sun.
Yeah, I mean that's the right answer, but it's extreme. It's called a runaway greenhouse effect. It's very extreme, and the sort of, you mentioned carbon dioxide, which is a pretty bad greenhouse gas, of course, that we have here on Earth. But the greenhouse, the atmospheric content of Venus is about 96% carbon dioxide, so it
Oh
has
my
an
God.
enormous amount. Yeah, it's huge compared to us. I can't remember what we are. We're about
I
half a
think we're at like
percent or
80
something.
or 85. Yeah.
Oh yeah,
I
well,
forget
one day.
I forget what the last statistics were from
Yeah, it's getting worse. But well, it turns out Earth, just for the record, Earth does need a wee bit of greenhouse effect as well. Otherwise, we'd be quite cold. We do need sun. It actually keeps us temperate and keeps water liquid, which is fundamental for life and for a nice cup of hot
gasoline
chocolate as well.
companies are like, huh? What?
What? We need
Useful?
CO2? Just a bit, not too much.
But I mean, that's a really, like, I mean, we're already experiencing negative effects of the greenhouse effect on Earth, and we're at like a couple percent.
Yeah.
Imagine, and if 95% CO2 is sufficient to turn Venus into the physical embodiment of hell, uh, like, I can't even imagine what's going to happen if we keep contaminating Earth's atmosphere the way we are.
Yeah, absolutely. Well, so we do this quite often, and I'm trying to keep us in check on this. We're using some technical terms, so we should maybe define what the greenhouse effect is.
Ooh, that's a great idea. Yeah. So for those that don't know, the greenhouse effect is a phenomenon that occurs when you have an atmosphere on a planet that is capable of reflecting infrared emission, basically back down to the surface. So
Yeah.
it's especially problematic if it's especially problematic if it's able to let in heat as well. But basically, if you have this atmosphere that that is capable of trapping heat, as the planet captures heat, it can't release it back and emit it back into space, and so over time, it gradually heats up. And there's issues that will occur. So that's just the regular greenhouse effect, and it's called the greenhouse effect because if you've ever stepped into a greenhouse, it's designed in such a way that the shape and composition of the glass and the greenhouse itself will let light in, and sort of let it bounce around and heat up the interior. Um, there's a variant of it called the runaway greenhouse effect, where as the atmosphere heats up, whether it's due to chemical reactions occurring due to the increased heat or due to just the characteristics of the planet itself, it will produce the creation of new greenhouse gases, which will result in planet trapping more heat, which will result in the production of more greenhouse gases, and eventually you'll have this exponential heat acceleration. And that's the runaway greenhouse effect, and why Venus's surface is hot enough to melt lead.
Yeah, no, absolutely. Yeah. So I might pick you up scientifically on one thing you said. Don't mind.
Okay.
You said that the atmosphere can reflect heat or reflect infrared. It actually absorbs it and re-emits it.
Right.
Reflect.
Yeah.
Yeah. So that's, I mean, I realize that's a sort of technicality, but we're trying to get some science out into the population here.
No, we should be precise. You're absolutely
I think
right.
that's what. Well, it's one of those things that, sometimes when you do these kinds of things, people can say, well, you didn't say that correctly. Well, we make mistakes as scientists, but the terminology is a very interesting one there. Because here on Earth, of course, a lot of the greenhouse effect is from CO2 and methane, but also water vapor. And water is wonderful at absorbing infrared light, and that's basically what the ground emits when it gets warmed up by the sun. And then it sort of makes the water molecule vibrate, and it makes it rotate, and then it re-emits that infrared back. Now, that direction can be random, right? It doesn't have to be out into space. It can be laterally or back down, and that's what's trapping the heat and why the atmosphere warms up.
So if it is if it's unidirectional, sorry, if it's omnidirectional, it doesn't matter which direction it gets emitted. Why doesn't it eventually just all randomly escape into space? Like, sure, some of it will get reflected back down, re-emitted back down, but eventually at some, if there's a 50-50 chance of it getting emitted into space, it won't get recaptured theoretically. So why doesn't it eventually just leak into space? It seems like what I'm saying is it seems like a pretty efficient cooling mechanism.
Yeah, and I understand it. It's actually a time scale effect, because if the surface, for instance, I mean, Venus must be doing something similar. If the Earth's surface is emitting infrared once it warms up, if the general direction is towards space, that may take, let's be generous and say, a couple of hours. I don't know the time scale, but let's say it's a couple of hours. But if it intercepts a carbon dioxide molecule or a methane molecule or a water molecule, does its rotation and vibration, and then re-emits, there's actually a really good chance of it, probably greater than about, well, whatever, it must be at least a half, it must be 50%, as you've said, because obviously 180 degrees that way or 180 degrees anywhere else, that it gets redistributed either sideways, laterally, or downwards. But then it can be reabsorbed by another molecule of one of these molecular species, or the Earth itself. So what that means is it could travel between multiple molecules, or the Earth, or a tree, or a building, many, many, many times. So if it would have taken 3 hours to begin with, it may take 300 hours for that one photon of infrared light to get out. Or during that 300 hours, many more infrared photons have been generated. So the net effect is the temperature goes up, even if that individual infrared photon will eventually make it into space.
That is really, really cool. The kind of random walk nature of that.
It's a random walk, exactly. Yep. You're sort of playing with the random walk effect. Yeah.
So the more greenhouse gases you have, the more steps you're forcing this photon to take in its random walk.
And that means that photon stays in Earth's atmosphere and effectively heats up the atmosphere. Yeah.
That is really, really cool. I love that explanation. You're so good at explaining stuff like that. I feel like science concepts like that in the news, like they'll talk about more greenhouse gases, Earth atmosphere heating up. But I feel like it's easy to disconnect yourself from the fact that what does it mean when we say that Earth's atmosphere is heating up? And it's literally, I'm not sure what I did there.
That was lovely. Was that greenhouse effect, or you're just happy birthday?
I don't know.
That's wonderful. That's going on the highlights reel.
Yeah, I have no idea what I did. I know if you do a hand symbol, it'll put something
really?
up, or it should have
balloons. How did you do that?
Okay, yeah. So if I do this, it'll raise my hand in the Zoom call.
Oh, you're right. There it is. Oh,
yeah.
I didn't know that. No,
but
really.
And it should be able to recognize a hand, but Oh yeah, here we go. Here we go. So like if I hold it up like this, it'll do that.
How did you get balloons?
I don't know how the hell I got balloons.
That's phenomenal. I love it. Love it. This is the
I
best
know.
video we've ever done.
This is, yeah. Sorry. Anyway,
Yeah.
but I feel like it's
No,
easy to
perfect.
disconnect when you say the atmosphere is heating up. What does that actually mean? And it's like literally the gas molecules in the atmosphere are retaining more
Yeah.
infrared photons. Like that's all that.
Oh yeah.
Um,
Well,
so
there's that
it seems
wonderful
just so,
effect.
yeah.
Oh, sorry to interrupt. Yeah, there's that wonderful effect where cloudy nights are almost always warmer because, of
Right.
course, you're getting effectively a localized greenhouse effect.
Oh, that's a
Now,
brilliant connection.
yeah, I mean that happens right when when there are no clouds in the sky, it can get pretty darn cold, even in the summer or in deserts, for instance, when there's no clouds. The temperature at night can really drop.
This makes perfect sense.
So
So, when you have like a vehicle emits greenhouse gases, right? Like a combustion vehicle. Okay, so that means like deliveries and stuff. Like planes flying all over the world, trucks delivering stuff, packages to your door. That puts out lots of greenhouse gases, right?
yep,
And
that's right.
so a local greenhouse effect can cause clouds. So does this explain why whenever I order new equipment for my telescope and it arrives, I get several days of cloudy nights, preventing me from using the new equipment?
I think you're just unlucky, Joseph.
Well, are you a climate change denier, David?
That's right. Clouds avoid me when I go observing, so it must be all you, my friend.
Yeah, you have. That's I think the mark of a true astronomer is your unnatural luck when it
I
comes to
know.
clear nights.
Sort of I'm like an anti-nublar or something, you know. Yeah. Well, so back to Venus, right? So all those
Yep.
clouds, they really do help us give that extreme greenhouse effect. But there's another natural consequence of that is that they are also good at reflecting sunlight, just like our clouds reflect sunlight at the top of the atmosphere. So Venus appears to be very, very bright. So it actually is, I think you mentioned at the start of the show, it's the third brightest natural object in the sky. And one of the biggest reasons is it has this very, very thick cloud deck. That
Really?
face you
Wait,
made
so
is
if Mercury was the size of Venus, no atmosphere, was at the distance of Venus, it wouldn't be the third brightest object in the sky. I'm sure there'd
no,
be a bit of a brightest difference, but oh,
it'd be much less faint, much less bright. So in fact, I think we talked about this maybe as we were putting the notes together. So the albedo, the reflection factor of the Earth, is about 36%, I think, something of that order, 34, 36%, which means from space, as you look at it, about 30% of the light is reflected back into space by the clouds, by the atmosphere, by the oceans, the landmass, whatever. On Venus,
36%.
yeah, well, on the Venus, it's double. So it's highly reflective, which is incredible when you think about it. Just incredible.
Oh my! I mean, to give you guys some context, like the brightest an object can be is 100% albedo, and the brightest objects in the solar system are like around in the 90% albedo. It basically tells you what percentage of your surface is acting like a mirror, effectively, just
Yeah.
reflecting all the light that comes on it. And to have, I mean, it sounds like you're saying it's around 70% albedo, which is just absurd for a planet. Like,
Yeah,
that's just
it's a
ridiculous.
little bit higher. I can't remember the exact number, but it's in the 70s. So I think it's over two times more reflective than Earth, which is why it's so bright. Especially, of course, because it's an inner planet, as in inside the Earth's orbit. You only see it either before sunrise or just before sunset, when it's highly visible. It reflects an awful lot of sunlight. That's why it's so bright.
I mean, like the kind of things that are in the solar system that are that bright are usually like icy comets and
Yeah,
like
yeah.
like just like moons that are just made of snow.
Yeah, pristine comments that aren't dirty. Absolutely.
Yeah, that's
Yeah.
unbelievable.
So I think you mentioned this, that you said the surface temperature of Venus is in the 700s in Kelvin, which is a scientific temperature. Sort of in sort of European or Asian or South American units, that's about 460 Celsius. In North American Canadian, oh my gosh,
Freedom
Canada.
units.
I know that we're talking about Fahrenheit. That's about 860 Fahrenheit. So the temperatures are enormous, and as you said, enough to start melting lead. So clearly, life is basically impossible at those kinds of temperatures. But we do know about organisms that are capable of living in very extreme environments here on Earth. They're called extremophiles. Now, is that possible in
Actually,
Venus?
there's a dude at my gym. I swear to God, he's one of those. He's enormous. I bet he could survive. I bet he could survive.
He could survive the pressures, yeah. Well, I'm glad you
Yeah.
mentioned that. Actually, he's like a big, strong person, because the atmospheric pressure at the surface of Venus is over 90 times the Earth's atmospheric pressure, which essentially is enough to
That's
crush.
so crazy.
It's incredible. Like you can crush. It would crush a car. It would crush us. It's sort of just incredible. So,
I mean,
but that's one
how
of the
far do
things.
you have to go? Can you even achieve a depth in the ocean that would hit you at 90? Like, how far would you have to go down and hit 90 atmospheres?
That is a good question. I suppose I could do a quick Google on this. I'm pretty sure the answer is yeah. Well, the answer must be yes, right? Because yeah, it must be because
Oh, so it's one atmosphere for every 10 meters of water depth. So you'd have to get
900.
900 meters down.
Wow, that's pretty
That's
deep.
ridiculous.
Yeah, that's what 3,000 feet knocking on the door of. That's
Yeah.
just off. That's where you're starting to get to the continental shelf area of most oceans. So it's pretty deep.
That's a really good like perspective. Like the equivalent of Venus's atmosphere is the equivalent of having like almost a kilometer of water above you. Like,
Yeah, right, absolutely. Well, that's incredible. So yeah, I mean, for humans, of course, we're not going to survive that. But that's a problem for things like spacecraft or life.
yeah.
But look, there is life down in the ocean at 3,000 feet. So clearly, biological systems can survive that kind of pressure.
Right.
But when you throw,
But is this the whole planet that hot? Like, is it that much pressure and that ridiculous temperature? Like, is there anything that's
I think so.
any part of it that's like cooler?
Well, so that's at the surface, right? So as you go higher up, you lose atmospheric pressure, of course, and you lose temperature. So I think as you get to really high altitudes, I think we're talking about 30, 50 miles above the surface, you're starting to get into temperatures at the range of maybe 50, 70, 100 Fahrenheit. So,
So
where life can
you're at Earth surface temperature, tens of miles above the surface of
tens of
Venus.
miles above the surface, right? So it's possible then there are extremophiles living that maybe so they digest carbon dioxide or I don't know what else is there. There's probably sulfur dioxide, nitrogen. Maybe there are those extremophiles, or maybe the cyanobacteria that can live in the upper atmospheres of Venus.
That's
Which would
ridiculous.
be amazing, amazing.
I mean, like for context, if you get that high above the Earth's surface, you're below 100 degrees Fahrenheit, like easily. And so the
Yeah.
fact that tells you how cold it gets, how quickly. The fact that you're just starting to get into beach weather on Earth when you're 30 miles up is just absurd. But okay, so you're saying it's possible these extremophiles could live at these heights, but in the upper atmosphere. Have we ever seen anything like that? Like any organisms that could possibly I mean, like not even like the crazy ones like water bears or like the those tardigrades, the weird animals that like they could survive
Tardigrades, yeah.
anywhere. Do you think they could?
Right. So the only concrete evidence we have for life in the universe is here on planet Earth. We've never discovered life anywhere else. But we do find these extremophiles living in sort of acidic volcanic pools of water near volcanoes, in these thermal vents underneath the ocean, where
That's where we think life began, right?
that could well be, yeah, absolutely. To make these sort of cyanobacteria, making sort of chains of amino acids. We don't know, but it would be wonderful to find out. I mean, what a great chance because they have energy. They have depending on what they metabolize, if it's CO2 or if it's nitrogen, why not Venus?
I imagine how crazy it'd be if there was like intelligent civilization in the upper atmosphere of Venus.
Would that be
Like,
brilliant?
that'd be cool. We could communicate with it. What do you think the first message would be? You have one new LinkedIn invitation.
God, it's hot. Please bring sunscreen.
Please bring some air conditioning.
Yeah.
Yeah. Oh my God. On Earth, like as you get closer to the equator, it gets hotter and hotter, and so like there are kind of like even zones on Earth that are sort of uninhabitable, almost uninhabitable. Like
Yeah,
as you,
almost.
but like we have like an association where like as you get closer to the poles, it's like less livable, and like as you get closer to the equator, it's a little bit more livable. But on Venus, I mean the whole planet's kind of hot. So instead of them like thinking about like longitude, a civilization on Venus would be thinking like the Santa Barbara of Venus would be like 30 miles up. And like, you'd have your polar bears and stuff like at like 100, 200-mile range.
Well, I'm glad you brought that up because Vivaldi would not be very popular there because there are essentially no seasons because there's no tilt to the axis. So they get all the areas of Venus get more or less the same irradiation from the sun at all latitudes. So we don't have that effect. So polar bears are going to be mingling with your palm trees. Just there's not that stratification in latitude on Venus.
I like the reference to Vivaldi though. You're right. He would have had to. It would just be the one season.
Vivaldi's one season.
And it would be 2 hours long of just screaming.
Well, much longer. I'm really glad you mentioned that. Do you know what the length of the day on Venus is?
What's the length of the day on Venus?
2,800 hours, I think. Yeah, hours. Because the planet is extremely slowly rotating. Its rotation period. So Earth's rotation period is 1 day, right? 24 hours. On Venus, it is 243 days.
That's so ridiculous.
Yeah. So it's 243 times slower than here on Earth.
2,800 hours. It's like the average length of Christmas Eve for a kid.
Yeah. Or Donald Trump's speech.
Wait, so is Venus almost tidally locked to the sun?
Not far off, actually. No, its orbital period is 220 days, or 225 actually. Its rotation period is 243. So it's definitely not tightly locked. But nor are we, right? Our rotation period is 1 day.
We're not, but I mean, isn't it like kind of the end goal of when eventually everything gets tidally locked to each other, or is that
No, I'm not sure that's true. It depends on the mechanism that is doing the tidal locking, right? Venus is a very odd one as well because we rotate west to east. Venus rotates east to west. It's rotating what we call in science retrograde. It's rotating backwards, which is really odd because most of the planets in the solar system rotate one way. Like let's say like this, my fingers making me dizzy. Let me do it that way. Rotating like this. Two planets in the solar system rotate in the opposite direction. One is Venus, and the other is
Uranus. But Uranus got smacked. Uranus got smacked as a child, and so that's why it's on its side, rolling the wrong direction. So what's Venus?
Hang on. Yeah, that's a great joke. We have to explain it, right? So it's on its side because when you say it's on its side, is if here's the sun. Most of the tilts of the axes, the rotation axes, are like this relative to the sun. Uranus is like this. That's what Joseph.
So it like rolls around like a wheel.
Yeah, it rolls around absolutely like this. It's very odd. It's the only one that does it. And the most natural explanation, of course, is that it was hit by something big, some meteor or comet or whatever. Well, that's probably the explanation for Venus too. But it's very odd because Venus's orbit, in all other senses, is relatively normal. It's in the ecliptic plane. It's in the line of the solar system.
And Uranus is rotating the wrong way, but it also is on its side, which kind of more intuitively feels like an impact. Whereas Venus is like Venus couldn't have less of a tilt. Like
no, it's three. The tilt is 3 degrees. It's like
that's none.
It's almost none. But so maybe it got hit. It probably did get hit, right? So it probably, if it did get hit, it probably got hit near the equator. And opposite to its rotation, right? So if it was rotating like this, something came in and hit it this way and made it go back the other way.
Wow, the odds.
I know the odds are just astronomical.
But disgusting. Was it Joe Buck that was like a disgusting act by David James on the field? He should be ashamed.
I know. It's the old astronomy joke, though.
Does that actually kind of makes sense though? If you imagine Venus had like some regular rotation and then it got hit exactly in the right direction to not change the tilt much, but with a comparable contributing a comparable. Oh, that's a plane going. Oh, wow, sorry, a very low aircraft. With a comparable angular momentum contribution, it would, I guess, if it was maybe a bit stronger, maybe it would have stopped Venus's rotation basically altogether.
Well, at 243 days, it sort of
It
has,
it
right?
basically did. That's what I'm thinking, right? Like
Yeah,
so that's really really cool. I
yeah.
wonder if there'd be any evidence of what what may have caused that collision, because with Earth's past collisions we have evidence of them, like the Chicks Club impactor, and I never know if
Oh,
I'm pronouncing that right.
no, I don't
Um,
know. Yeah, impact is such a hard word.
Chicxulub. No. Oh God, I was not expecting that. Um,
You weren't expecting that. I got you on that one.
you got me. You totally got me on that one. But so like
Yeah.
with, obviously, since Uranus is a gas giant, the evidence is, if there's any evidence at all, it's presumably hidden beneath the. It doesn't really have a surface to collide with. But I wonder if Venus would show some relic of collision long gone.
Well, indeed. Although I think we have been very amiss and sort of remiss, sorry, a very sort of disgustingly poor scientists here. We have not shown any images so far. So do we
Yes.
do we have any images of Venus?
Yeah, absolutely. So we were talking about the phases of Venus earlier, and we have this really nice figure of how the phases of Venus look.
Ooh, look at
Yeah.
that.
So is this what you saw when as a child when you were
That's
doing Venus
exactly it.
PhD?
Yeah, I actually made this image.
I am. This is me in the image. This one's
Yeah,
me. I
that's
am.
right.
This is a picture of
That's me.
me.
Me as a 7-year-old. Yeah, I think I saw something similar to one of these middle rows actually.
Okay.
Yeah, it's just incredible.
That's that's amazing. Seeing her as a crescent, like that's wild.
Yeah, it was super duper. Yeah, it's just the angle of the Earth, Venus, Sun system must have been just right to give it one of those lovely crescents.
So I've
Which,
got a strange question here.
okay.
How do they capture an image like this in the bottom right? Because that looks almost like a new moon, which I know is when like the object is in between us and the sun. But if the object is between us and the sun, there's no way you'd be able to look at Venus with a telescope.
No,
So
that's
is it
true.
like a transit or from a spacecraft?
That is a great question. Well, again, even if it was a transit, you'd have the background sun. So unless they sort of photoshopped it or edited it out with or used a fancy coronagraph, I suspect what it is maybe the sun is almost in line, maybe 5 degrees off or something like that, and what you're just seeing is the atmosphere of Venus being backlit, and there's just a very uniform distribution of light.
I
But you're right;
see.
it does look incredibly uniform.
I know. You ever see
Don't,
the you ever see the YouTube videos where it's like some horrible like some tragic horrible explosion or something that seems to be causing a ton of damage, but somehow like the cameraman is like unharmed. I'd like to know how the cameraman did this shot, you know, it's floating out in
yeah,
space.
I don't know. That is a really good question. I don't know is the answer.
But it is, Venus is absolutely stunning, being able to see the faces like that.
Oh,
So
absolutely, it's phenomenal.
how come we don't see pictures like this for Jupiter and stuff? Like I've only ever seen this for Venus and Mercury.
Well, so I think the obvious answer has to be that we're looking inside our orbit, and so we see the Mercury and Venus. That they both show phases. You're seeing them as they rotate around the sun, and you're seeing the angle change. With Jupiter being an exterior planet to the Earth, there you always see essentially a full face illuminated. But don't forget, Earth is also moving very, very quickly. And so we never essentially get in position where we could see a phase. So I think you're always seeing effectively a full face of the outer planets.
That's really cool.
Yeah.
So if that's the case, then does Venus have a meaningful opposition like Jupiter and other planets do, where there's like a point where they look brightest because they're on the opposite side of the sun?
Yes. I think the answer to that is definitely yes, because obviously that is where you're seeing the fullest illumination. But they're also then farthest away from the Earth because essentially they're on the far side of the sun. Maybe not directly in line, obviously, because that would effectively be an eclipse. But they're probably just offset by whatever 10 degrees.
Or maybe the tilt of their axis.
Well, no, but don't forget the tilt that we mentioned earlier on that the Venus actually lies in the ecliptic plane as we do. So
All right. Oh well, so opposition wouldn't be other side of this. It wouldn't be covered by sun because opposition is when it goes sun, Earth, and then planet. So I guess Venus can never
uh,
have an opposition, I guess.
Well, I was thinking of inferior conjunction. So
Yeah, I
inferior
think conjunction, but opposition is
conjunction.
when the
Okay.
planet looks brightest.
Well, but
Right.
that would have to be at the far side, right? When if we're
It,
here and the sun's here, it'd have to be the other side for us to see
uh,
the full disk.
let me check. I think conjunction is when it's on the other side, and then opposition is when it's on the same side, because then it's fully illuminated by the sun with nothing in the way.
Oh no, you're right. Yeah, yeah, I got confused by that. Yep, you're right. I apologize.
It's okay.
So yeah,
There's
so
only
what
1,400 different terms.
I know.
For every
It's been a
goddamn
while.
angle of a planet's orbit.
I know there's so many. Yeah, no. So you're 100% right. I apologize. So yeah, those two. Well, conjunction opposition. Well, hang on. We can't. No, in that case, I don't understand. We can't. Venus can't have an opposition because it's
That's what I'm
inside the
thinking.
Earth's.
I don't think Venus can have an opposition at
Oh
all
no,
because,
okay. That's why I was
yeah,
confused. There's no opposition.
yeah,
Yes,
but
because if you
Venus
look at
does have it's the inferior. I think this is what you're talking about. The inferior conjunction is the
yes,
equivalent when Venus looks the largest because it's closest. But
yeah,
at an
but it's
inferior
back illuminated.
conjunction, that's exactly what I was going to say. At inferior conjunction, when it's closest, it's going to be it'll be as close to the sun as it could be. So
Yes, but you don't see the illuminated side at that point. So
right.
you see the full face of it here at sort of superior conjunction when it's round the back, or at least conjunction, as if it's superior, you can't see it. But
Yep.
you see the full face of Venus, but it's much farther away from the Earth because
Right.
depending on the Earth's position, in fact, it must be at least 1.7 AU. Yeah, about 1.7 AU. So that's a really nice image, actually. So
I
one can
actually really
imagine
like
with
this
the
diagram because it explains what we were talking about too with the phases. Why you can only see it for the interior. Like you can from the Earth, you can clearly see the
yes,
phase, but then for the
that's right.
external ones, you can never see the black part of the planet, like the planet part of the planet in shadow.
Well, you can actually at greatest of eastern and western elongation because you see a half phase
Sorry for the
from the.
interior planets, but I'm talking about for the exterior planets.
Oh yeah, correct. That's
Yeah,
exactly right. That's exactly right. Which is what we said, right? When we talked
right.
about it, is the fact that when you're on the outside, you essentially see the full disk of the planet.
Yeah,
Yeah,
but I think this just visualizes what you said really nicely.
Yeah, absolutely. Yeah.
Yeah.
Yep. Yeah, that's a nice. I'm glad you pulled that up. It's complicated. Planetary dynamics
It is.
are not simple things to envisage in your head.
So, I know for like this elongation term. So, what does this look like in the sky when something's at its greatest elongation?
That's a great question for the inferior planets, which we're talking about Venus here. That means it's the farthest the planet can appear from the sun. Now, for Venus, that turns out to be about, I can't remember the exact number, but it's about 45 degrees, which is why you never see Venus in the middle of the night sky or the middle of the daytime sky for that matter. You always see it within about 45 degrees or less of either the setting sun or the rising sun. Because, of course, as you look in from the Earth inward toward the inner solar system, you're looking more or less, as this diagram shows very nicely, the maximum position of the inner planet from the sun. And you can see here, this actually looks not far off the Venusian system. It looks to be about, I don't know, it does look to be
About half the distance.
About, well, 35, 40 degrees.
Yep.
Yeah.
That's super cool. Sorry.
Yeah, well, this diagram actually explains really nicely why people get Jupiter and Venus confused, and it's almost impossible for that to happen. Because if you see Jupiter, which is a bright object in the middle of the night sky, and my children have done this, they've looked up and said, "Oh, is that Venus?" And I'll say, "Well, can it be Venus? Where's the sun?" They say, "Well, the sun is set." So I'll say, "Well, can that be Venus?" And they'll say, "No, because Venus is close to the sun." Children visualize this really well, actually. And so
maybe your children, because your children are geniuses.
Well, I wouldn't go that far, but they make they make wrong inferences just like the rest of us. But they're pretty sharp at this stuff. We lived in Hawaii, and Benjamin was about, I don't know, he was about 2 or something, and he was always very talkative and very bright. We would drive home, and I would say, "So, what's that over there?" And he'd say, "It's the moon." I'd say, "Well, what phase is it?" He'd say, "Well, it's about half moon today." I said, "Yep." And then we'd see Venus. I say, "Well, which planet is that?" And he'd say, "Well, it's either Venus or Jupiter." I'd say, "Why is it Venus or Jupiter?" I mean, bear in mind he was 2, right?
That's amazing.
But I used to talk to him about
2
Yeah,
years
well, I used
old.
to talk to him. Yeah, but I used to talk to him about this stuff all the time. And I'd say, well, it can only be Jupiter or Venus because it's really bright and it's sunset, you know. And he said, and I said, could it be Jupiter if it's near the sun? And he said, yes. I said, well, it could be Venus too, right? How do you know? And he said, well, I don't know. I said, well, I don't know either without a telescope. And so, you know, I teach him those kind of things. But in the middle of the night, or if he was up, if we were out, and you know, occasionally I would take him to see the stars at night. I'd say, you know, that thing up there, is that Jupiter or Venus? And he'd say, well, it's either Jupiter or Venus. I don't know which without a telescope. I say, but where's Venus has to be close to the sun, right? And you say, oh, right, so it has to be Jupiter. So yeah, even as a
It's
two-year-old, he was like,
amazing.
yeah, he's phenomenal with that. Like the
Your kids,
basics of
man, they're so lucky to
I
have you.
know. Well, you know, we used to talk about this stuff, but yeah, these boys are strong.
I do get asked pretty frequently. Like, someone will see like, you know, either Venus or Jupiter, especially because they're so bright, and they're like, "What you know, what am I seeing?" And oftentimes people will be like, I'll just tell them if it's Venus or Jupiter, and they're like, how can you tell the difference?" And I'm
You
like,
can tell.
I think the most people, a lot of people haven't seen Venus because you have to get up kind of early to see it. Um, uh, or be out right around sunset when it's on the
That's right.
other side.
That's right.
But a lot of people like see it and don't know what it is. And so I find that it's like I find that people think Venus is Jupiter. Oh, sorry, I find that people think Jupiter is Venus a lot of the time until they've actually seen Venus, and then you cannot mistake it. Like it's
That's right. That's
Venus
right.
is stupidly bright. Like, and
It's
it's
very bright.
huge. Like you can almost feel like you can see the surface. Like that's how big
Yeah.
it looks. Like it's like it like you can almost see like a disc with your eye. Like it looks so
Yeah.
ridiculously bright.
Well, I think out in the desert or in dark sky areas, Venus, I think Venus casts a shadow, and I don't think Jupiter does, at least not very well.
I
So
would be
it's,
very surprised if Jupiter casts a shadow.
yeah, I think it subtends quite a small angle on the sky, where Venus is a bit bigger, but it's just much brighter. And so yeah, I've seen my own Venusian shadow on the Earth. It's actually lovely. It's sort of like,
That's
what the heck?
magical.
Oh, it's amazing. It's just beautiful to see, actually. So I think we have another.
Yeah.
We should save this image. I
Yeah.
actually love this image. And we have another image to see, and it's actually the surface. If we have it, yeah,
Oh
look
yeah.
at that.
This
So
is
this
so
is
this is from the Venera spacecraft launched by Russia. They understandably had to try many times before they succeeded in landing with all systems operational on Venus. Because you know, like when we first explored Venus, we didn't know anything about it. When they first sent probes, they thought it was like Earth, because it had similar size, and it's like, you know, we're all in the same neighborhood. And so they thought, you know, the earthification of the inner solar system was such that all the rocky planets were basically like Earth. But the Venus had this really thick layer of clouds that made it impossible to see anything underneath. And even with like advanced radar imaging and stuff, we were only able to notice that like one part of Venus was more radio bright than the other, and they called that the alpha and the beta regions, and that was like the extent of our Venus knowledge for a long time. But when they first started spending spacecraft to check to see, hey, is this like Earth, they quickly realized that the atmosphere was, you know, hundreds of degrees, and like the whole thing was basically like sulfuric and boiling, and so when they finally did start sending landers, they had a lot of difficulty building spacecraft that would not simply get destroyed within 5 seconds of landing on this ridiculous planet. So, but they
yeah,
did, after many tries. Various spacecraft were able to land on Venus, and we got these beautiful pictures of the surface that just look incredibly like they're very uncanny valley. Like they almost look like a
yeah,
false color image of something on Earth.
yeah, absolutely. Well, also just that rocky structure that could be, you know, like the sort of South Dakota Badlands, or you know, the Monument Valley, or various other regions of the Earth. It's just these very. I mean, it looks dry. Obviously, at 700 degrees, it's going to be pretty dry. But
Be
you know,
careful,
there's
David. You're going
different.
to start a conspiracy theory that the Venus landings were filmed on a soundstage in South Dakota.
Are you still there?
Oh, sorry. Oh, the connection dropped for a second. Sorry.
Oh, there you go. Sorry, you're back.
You're going to start a
Uh,
conspiracy theory that the Venus landings were filmed on a soundstage in South Dakota.
yeah, that's right. That's right. But I mean, it does. It looks like that. It looks like this very sort of flaky, sort of sandstone, possibly. it doesn't even look like granite. It looks like sandstone strata.
It kind of looks like a lake bed.
It kind of looks like an old lake bed, absolutely.
Yeah.
And the image you have below it also looks very similar.
Yeah, and
Yeah,
like
I mean,
these like the pebbles, and I just look
yeah,
so similar. And this is obviously
incredible.
a bear trap that they landed in,
Yes.
protect
Or
against
a
Venus bears.
circular saw that lost its teeth. But they're
Yeah.
just incredible. In fact, you can see some
Yeah.
mesa there off in the distance. It's just gorgeous.
I know. This image is from Don Mitchell. He sadly did not make it back.
No, that's right. He's a tourist.
It's like for my with my last breath, I upload this to Instagram.
That's right.
It's like,
Yeah, so
what up,
I
what up,
bet you,
guys? Coming at you live from the surface of Venus.
well, not for long. But no, I'm glad you mentioned
Sorry.
that. We should reference these images. Most of our images actually come from NASA sources, but yeah, this is a
Yeah.
Don Mitchell. So actually, that's what we know about the more or less to this day what the surface of Venus looks like through either landers or through radar imaging. It turns out there are over 160 volcanoes on Venus that are greater than 100 kilometers or about 62 miles across, which is incredible. So we have a lot of volcanoes here on Earth. So it's, again, sister planet, not dissimilar. So it's incredible. Probably one of the greatest sources of its atmosphere. Maybe it's volcanic outgassing, which is, obviously could be a source of Earth's substantial atmosphere.
That was why I caveated my statement about the runaway greenhouse effect, because I was sure that Venus had had surface level contributions from the volcanoes and stuff that contributed to it, and I didn't want to just say it was because of the increased heat. But for all we know, I mean, the ridiculous pressures and stuff may make it more prone to volcanic activity. Like
that's possible too. Yeah, absolutely. Yeah.
Again, yep. Sorry, go for it.
Excuse me. Sorry. Well, if it did get impacted by some large object in its past to have changed its orbital motion on its spin axis or its spin rotation, that could have well triggered a very intense period of volcanism as well. So the atmosphere could be a leftover from that very extreme volcanism.
That's really cool. And looking at these pictures, like the sulfuric volcano covered surface, the blistering temperatures and pressure, like literally poisonous air. Okay, a genuine question. Like, is this a case of science imitating art? This seems like an exact description of the Christian hell.
Yeah, that's right. So Dante's Inferno.
Yeah, like I mean, I'm pretty sure this
yeah.
is one of the levels, right?
Yeah, no, absolutely. Yeah, well, it's just an extreme environment. But look, we have those here on Earth too. I mean, I don't know. I'm not sure we should be so surprised. It looks this could quite easily be on the side of some volcano, in Indonesia or Central America. You wouldn't be surprised if this was something similar to that.
And if this was really hell, I'm sure there would be some, corporation who you pay them $10,000 and they'll shuttle you out.
Yeah, that's right. That's right. Yeah. Pay to play.
Yeah, pay to live. So we've got one more picture too. So this really cool picture, as I know you're interested in the magnetic field of Venus. So can you tell us a bit about that?
Yeah, so the funny thing about Venus and its magnetic field, it's sort of multifold, but because it rotates very slowly, Venus doesn't generate its own magnetic field in the interior. It probably has a similar interior structure to Earth. It probably has a molten iron core, something very similar to that. The density of Venus is pretty similar to that of Earth, but its slow rotation rate means you don't, if you have slow rotation plus a liquid metallic core, you can't generate much of a magnetic field if the rotation rate is low. That's how we get Earth's magnetic field, right? It's sort of that Faraday effect. But if you don't have a strong magnetic field, one would imagine that the solar wind, which you mentioned earlier on, would ablate away or burn away the atmosphere. And that's not a heat effect. It's just all these incoming particles just basically knocking into the atmosphere, giving a lot of kinetic energy, a lot of rotation energy to the molecules, and they end up then escaping from the atmosphere.
And it's a significant effect. Like even with Earth, which is a very good magnetic field, top notch, made by Apple. Sorry, even though Earth has a very strong Earth has a very strong magnetic field, but we still get thousands of tons of atmospheric stripping per day due to the
Oh
solar
yeah,
wind. Do you
no,
think
absolutely.
Venus would be getting like torched?
Yeah, absolutely. It's much closer to the sun, and its intercept angle is far greater. But it turns out Venus does generate a magnetic field in the atmosphere. And
Whoa.
essentially, it's an ionization. It's actually from the solar wind. It's an ionization effect. These very high energy particles come in and they interact with the CO2 primarily and the nitrogen, and they strip off electrons. And when you take away electrons from an atom or a molecule, it becomes ionized. And with ionization, an electric field can be generated, which in itself generates a magnetic field. And that ionization is so high, the magnetic field turns out to be somewhat global in the upper atmosphere of Venus. And then it's able to deflect, as the graphic here is showing, this is from a 2021 paper in Astronomy and Astrophysics. It generates a high enough magnetic field that it can then deflect the solar wind. So I suspect it must be a game between ionization, magnetic field protects it, the protection reduces the ionization. So the magnetic field, I suspect, oscillates between very strong, reducing the ionization, so it drops a little bit, ionization increases, more magnetic field, and it increases again. That would be my
So it's a coincidental stable equilibrium for the strength that's so bizarre. I wonder why we don't see it on more planets, or how lucky we are that Venus just happens to have this incredibly unusual like balance.
Well, I mean, you don't see it on Mercury because Mercury has essentially no atmosphere. I mean, it has a
But that's exactly
tiny,
what I
tiny.
mean. Why didn't the ionization, as it was being stripped, as the atmosphere was being stripped, if it had an atmosphere in the past, why wouldn't it have this effect have applied?
I don't. Well, again, if you go inside Venus's orbit, the flux of particles from the solar wind is also very much greater. And so I suspect what happened is that the density was reducing quickly enough that the ionization and magnetic field buildup just couldn't happen quickly enough to protect the atmosphere.
So what you're saying
That
is
would
there's
be
a
my guess.
habitable zone for magnetic fields?
That could well be true. That could well be true. But I mean, it clearly doesn't work very well on Venus, for instance, Mars, for instance, because Mars has a very thin magnetic field, doesn't have a strong internal not geo,
Like an
geological
internal
magnetic
dynamo,
field.
yeah.
Internal dynamo, thank you. That's exactly what I was looking for. So that's probably where the equilibrium got lost as well. And then obviously when you get to Saturn and Jupiter, they have extreme rotation rates. And the solar wind out there is really, while it's still quite strong, right? It's still doing 400 kilometers a second, more or less. The flux density is much, much less because, of course, the opening angle as you get farther away from the sun becomes greater. So the larger gas giants intercept less and less of the solar wind.
So our atmosphere, though, where does it lie? It's not that ionized, right?
Well, the upper atmosphere is. I mean, there is the upper atmosphere, which is called the ionosphere. So yes, it
But
is.
no, but I mean, I feel like if like we know our primary magnetic field is a result of the Earth's internal dynamo, like the core,
Yes.
the rotation of the core. If there is an equivalent, like a magnetic field of comparable strength in the upper atmosphere, it would be affecting our technology, and we would be able to detect it, right?
Well, I think the magnetic. Don't forget, the magnetic field is almost like an onion, right? It's got the sort of internal field lines are like this, and they get sort of more and more stretched out as you get farther above the Earth's surface. And I just think most of the Earth's atmosphere is inside that magnetic sort of field onion effect. I'm pretty sure that's
From the geomagnetic field or from the ionization.
from the geomagnetic field.
So that's exactly what I'm wondering. Like uh if the Earth did not have as strong a magnetic field as it has, would that even matter, or would we be kind of seeing the same effect Venus is?
Well, that depends. That's a good question, but it depends on. Don't forget, the solar wind is also less dense here than it is at Venus,
Right.
just because of again the opening angle. But it also depends on the source of Venus's extremely dense atmosphere. Don't forget, Venus has a 92, 93 mass times atmosphere than we do. So that has to be coming from somewhere, like I said, presumably volcanic outgassing or maybe some chemical reaction at the surface. But our atmosphere is very, very much more tenuous than Venus's. which means if we were being impacted by the solar wind to that great an extent it caused ionization and a subsequent magnetic field, just naturally the magnetic field would be much less, I suspect.
Okay. Guys, let us know in the comments if you'd like us to do a future video ranking magnetic fields in the solar system in tiers. Astraveo, because it's better than watching paint dry.
I quite like our Astraveo chats. What are you talking about?
No, that is I first of all, I absolutely love our chats, and I think actually, as although I was joking, that a tier video rank, like a tier ranking of the different solar system planets, either by quality or just how we feel about them, I think would be a very fun video to make.
Absolutely. So. Well, it has to be somewhat scientific, right? It can't just be I like Jupiter because it's pretty.
I like Jupiter
there's nothing wrong
it
with
makes
that.
me look like a great astrophotographer.
There you go. There you go. But yeah, we could do it science-based, like number of moons or Io being volcanic or
I think number of moons would be too boring. But
yeah, that'd
I do
be too
think,
boring. I agree.
But I think I like in general how much we like the planet based on scientific stuff, like how interesting it is. I think that could be one of the most interesting planets. That would be a pretty fun one.
Well, we could kick that off right now. Off the top of your head, what is your favorite planet?
Ooh. Oh my God. Planet Fitness. We gotta go. The OG. Sorry. Sorry.
This is where people turn off the video.
Yeah, I know. I had the sharp drop in the YouTube analytics. Either that or at Impactor.
That's right. Right. If those jokes continue, I wouldn't buy my own Impactor right now.
I think I'd have to say Saturn. I have this I think it's so beautiful. The ring system is so fantastic. It's such a dynamic system, and has so many open questions. And I always it's always so wild taking pictures of it. I think I'd have to go with Saturn. I think it does have a lot of wins in the interest department as well. Like the moons are really cool. You've got Enceladus. Which is potentially our best chance of finding life in the solar system. And it's got the fantastic ring system, the polar hexagon, the rings. And it's got, these incredibly interesting questions that we try to answer about the structure of its atmosphere, and it's got its rings. And also the rings.
I think you mentioned rings about 12 times. It's not the only planet with rings, by the way.
I know. But I mean, you can't. Oh, what's Jupiter gonna do? It's little sissy ring system. Like I want the big boy rings on Saturn.
Yeah, they're pretty juicy. I'm gonna give you that one. Yeah.
What about you though? Like, what would you be? What would your favorite planet be?
Well, it's a toss up for me between Dagobah and Tatooine.
Because of the rings, right?
Because of the rings, right? Yeah. Yeah. I never did enjoy Coruscant very much. I don't know. I mean, obviously, we have to exclude the Earth because Earth is pretty interesting from all the various things we know about, right? But
I think saying my favorite planet's the Earth would be kind of. I'm gonna forbid that one.
Yeah, we have to forbid that one. Yeah, we have to exclude the Earth, obviously. But I have always loved. I agree with you with Saturn. I think Saturn's just phenomenal. The ring system, the shepherding moons, Enceladus, as you said, with its sort of potential water geysers. I've always loved Neptune, always.
Oh,
I know the blue color it's just gorgeous. I mean, the blue color has recently been downgraded to a sort of greenish color, but it's all that methane, capturing the, cutting out the infrared as it's always absorbing all that infrared. The massive storm on it, similar to Jupiter's Great Red Spot. It does have a ring system. Occasionally it goes outside of Pluto's orbit. There's just a whole bunch to love about Neptune.
I'm the whole thing about the color getting downgraded, which the color of those pictures was one of my I loved how crazy it looked.
Blue.
And now it turns out it looks more like Uranus. A brown with some stripes. Sorry. Maybe we should edit out
Well,
that one.
yeah,
um,
it turned out that it was image enhancement, so that that great storm looked more,
yeah.
like popping, like the contrast of the storm. But
So,
it's
but
still,
like
I mean, it's still,
but the thing is that like if you look at the images, like the new Neptune, they when they show the new color, like you said, they downgraded it quite a bit. And here we go. It looks basically very Neptune like, sorry, very Uranus like. And something that
yeah,
was
which
really wild
makes sense
was
giving its competition.
it does, yeah. But one of the things that was I thought was really wild was when I made my first images of Neptune, I actually observed this as well, that it looked exactly like my images of Uranus. But when you crank up the saturation on Uranus, it stays roughly the same color. If you crank up the saturation on Neptune, it turns into spectacular blue. And I
Yeah.
assumed it was because of my optics that like I wasn't able to get sufficient dynamic range or sufficient contrast or something to produce the color without processing it afterwards. And bumping up the saturation is not the craziest astrophotography post-processing thing that's ever been done. And so I didn't mind it. But I couldn't believe it when I saw like 2 months later that somebody did effectively this and then wrote a paper and was like, actually, Uranus is not blue,
Mm-hmm.
or rather,
Yep.
Uranus is not blue. And I think it'd be a really fun video to like put this to the test and say like, you know, what's the real color of Uranus? And we could do something like pick another planet, calibrate our processing to it, where we have a better sense of the color, and then reproduce the image of Neptune with that
Mm-hmm.
exact processing and see what the color we
Yeah,
get
yeah,
is.
that's a good idea.
So,
Yeah,
but
that's a good
I
idea.
love that you brought that up, the image change. I'm so fascinated by that. Even Hubble though, like looks bluer than those guys made it, and I
Yeah, but don't
just
forget these images are also sort of made by humans who apply their sort of
mhm,
color algorithms, and they could have for people who were doing it for Hubble, they may have based it on earlier 70s and 80s images, thinking, oh, we've got to make it blue, and so they give it that
yeah,
deliberate blue tinge.
that's a little alarming.
I think it's human nature. Actually,
Yeah,
I do. I really do. You go on past experience, and you don't want to be too different from everybody else. I mean,
I do.
look at the gorgeous
I,
ring systems as well. Oh,
oh yes, the JWST images of Neptune are just
that's gorgeous.
spectacular.
Oh, just gorgeous.
They're
Just gorgeous.
phenomenal. I love the JWST images of all the planets, but like the in
Yeah.
particular, for some reason, Neptune and Uranus had me rolling. Uh
Yeah, well,
oh,
especially I love that's pretty cool too. Yeah, that's just phenomenal.
just
Yeah,
breathtaking.
yeah,
The
very
subrings.
gorgeous.
Yeah,
Yeah,
these
I
subrings
love
are
the
caused
submarine.
by a little joke for you. These subrings are caused by gravitational lensing of a Uranus. And they
Oh
actually
dear, dear,
they
dear.
add up to contribute to the n equals zero Uranus ring.
Can I resign from the company? That was pretty bad.
So
All right. Well,
I think that's all the images we had. Yeah.
yeah, no, absolutely lovely. So I think we should wrap it up. We've talked Venus to death a wee bit, but we
Yep.
said that we might have a little competition, a little maybe a raffle type thing. So the question for the video is behind me here, me looking much younger and wearing some interesting clothing, is me building a telescope, as you can see, or putting the dome together. The question for the video is, on which mountain was this telescope built?
And I know this one because I've been following David as like a paparazzi since his early days.
Oh
um,
dear.
but I know this one was taken at Mauna Kea, right on top of in Hawaii, back in your days when you were a University of Hawaii professor, right?
Absolutely. You're very good. Very good. It's the Hoku KR telescope that I was building the dome there. The telescope equipment hadn't arrived yet. You can see some sort of digger
Is
here. Here's
did you
the
have
heart of
Amazon
the
Prime?
shell. No, definitely not. It was way too big for that.
Probably would have arrived faster.
Yeah, I know. That's right. It probably would. Yeah. But this was the wall of the observatory that I built a few days earlier, and we were just about to put in the half shell of the observing dome that morning. Yeah.
It's a spectacular image, and I hope you guys appreciate how lucky you are that and I feel very lucky that I get to sit here and chat with David, and we get to talk to him and deep like dive into his incredibly deep well of astronomy knowledge because like I'm just a PhD student right now, but David was a professor of astronomy, and he has been in this field for literally decades. Like I like to make the joke that David and I have a combined half century of experience, but it's really mostly him. You know,
I'm not that old.
it's sort of like I like to say, it's like sort of like when I say Tom Brady and I have won a combined 7 Super Bowls.
Oh my God, that's ridiculous.
Maybe that should be the video question.
How many Super Bowls has Joseph won?
Combined with Tom Brady. It's it's super cool, and thank you for sharing that bit there. And so we have I'm very grateful and lucky to have access to you via both this format and our friendship in general to pick your brain about space stuff all the time.
Well, you're welcome. Thank you for that, Joseph. You know an awful lot too. You should put
yeah, about dad jokes. Yeah, David comes to me when he's like, "How do I need new jokes to annoy my children?" He's like, "Joseph, just talk."
That's right. You just laugh your way through most jokes. Like that. So, well, I appreciate that, Joseph. I can't play the ukulele like you can. You should have been with me there in Hawaii playing the ukulele. That would have been good.
Oh, that would have been very fun.
Oh, it would have been very fun. So, okay, well, this has been really cool. Yeah, so let's wrap it up. It's been really cool. So thank you. Well, this wraps up another presentation for Astraveo, where we go from geek to chic by sharing our passion and excitement for all things scientific, especially astronomy and in the mysteries of the universe. If you enjoyed this video, please hit the like button, and in the comments below, please leave us your suggestions for future presentations. We'll get right on it. And don't forget, you can join us on our journey by subscribing and hitting that bell. He's Joseph, and I'm David, and together we're Astraveo. Thanks for watching.